Hello everybody and welcome. In today's video we are going to be solving some pretty beginner trigonometry problems. You should be able to solve these problems if you've already watched my SOH-CAH-TOA video. It's going to be 10 problems, a quick word problem, a few simple find the missing component problem, some special right triangle problems, and then some advanced missing component problems. So timestamps are in the video description if you want to skip to a specific part, but let's go ahead and get started. So for this first one, draw a right triangle with sine of x equaling to 12 over 13, then find the lengths of all three sides from shortest to longest, and find the measures of both acute angles, round to the nearest tenth. Okay, so let's draw a right triangle. And how can sine be equal to 12 over 13? Well, we need to remember SOH-CAH-TOA for our trigonometry. And what does the SO part of SOH-CAH-TOA mean? Well, it means the sine of some angle theta is equal to the opposite over the hypotenuse. So in our right triangle, if we have some angle theta, then the opposite side must be 12, and the adjacent side, or I'm sorry, not the adjacent, the hypotenuse must be 13. All right, so we need to find our missing side length. How can we do that? Well, to find our missing side length, we can just use Pythagorean's theorem. Pythagorean's theorem is that a squared plus b squared is equal to c squared, and we can plug in these values. 12 is a leg, and 13 is our hypotenuse, and we're missing the second leg. We're missing our b squared. So we have 144 plus b squared is equal to 169. We can subtract 144 from both sides to see that b squared is equal to 25. Therefore, we take the square root and b equals 5. So the missing side component is 5. Okay, now we want to find the two missing angles. We want to find out what theta is. So how can we do that? Let's go ahead and change colors. Well, we know that sine of theta is equal to 12 over 13. So how can we find what this angle is? Well, we can apply the inverse sine function, and it will peel away the sine function to just leave us with theta. So if we apply the inverse sine function to both our left and right hand sides, then we have the inverse sine of 12 over 13 is going to be equal to theta. So let's go ahead and plug that into our calculator. So we have 12 over 13 equals some value, and then we're going to apply the inverse sine function, and we see that it's 67.38 degrees. We're rounding to the nearest tenth, so this is going to be 67.4 for theta. And then if we want to find the other angle, let's call it alpha. The other angle can be alpha. We can just subtract 90. We can do 90 minus, so for alpha, let's get another color. Alpha is going to be equal to 90 minus theta. And so 90 minus 67.4, let's not mess up. Let's just subtract 90. And we get 22.6 once we round to the nearest tenth. So this is going to be 22.6 for alpha. So, oops. Let me scroll down a little bit so you can see the work again. To find the missing angle alpha, we just did 90 minus theta, as both theta and alpha must sum to be 90 degrees, as this is a right triangle. So if we just subtract 90 from our already known angle, then we will have our second unknown angle that I called alpha. Excellent. Let's move forward. Solve for the missing variable and round to the nearest tenth. Okay, let's start with this blue triangle. Scroll down a little bit so I don't get in the way. So what do we have? Well, our unknown is our hypotenuse, and our known is our opposite side to our 15 degrees. So when we think of SOH-CAH-TOA, you should be thinking that we're going to be using our sine function, and we should be thinking that sine of 15 degrees is going to be equal to 7 over x, and then we just need to solve for x. So we can multiply both sides by x to get x times sine of 15 degrees is equal to 7, and then we can divide both sides by sine of 15 to have x equal to 7 divided by sine of 15. Now this is something we can just plug into our calculator. So let's go to our calculator and have 7 divided by sine divided by, I'm sorry, 7 divided by sine of 15. And we are in degree mode. And so this equals 27. This equals 27. So x is approximately length 27 here. Excellent. Let's go up to this green triangle. Here again, we need to be thinking of SOH-CAH-TOA. What two measurements do we have in terms of alpha, our unknown angle? We have the opposite side, and we have the adjacent side. So when we think of SOH-CAH-TOA, we're going to be using tangent, such that tangent of our angle alpha is equal to 10 over 24. And then if we want to know the value of alpha, we're going to apply the arctangent function to both sides. Therefore, we're going to have alpha equals the arctangent of 10 over 24. And we can plug that into our calculator. 10 divided by 24 is 0.416 repeating. And we're going to plug that in to our arctangent function. Oops. Let's do this again. 10 divided by 24 is this value, and then we put it into arctan, and we get 22.6. So alpha is 22.6 degrees. Excellent. Let's look at this last one in this beautiful blue color. Here, in terms of theta, what do we have? We have our adjacent side, and we have our hypotenuse. So we're going to be using cosine for our trigonometric function. So we know that the cosine of theta is equal to our adjacent side, 27, over our hypotenuse, 45. Now again, we want to solve for theta. So what are we going to do? We're going to apply the arc cosine to both sides in order to peel away the cosine function and have theta being equal to the arc cosine or inverse cosine of 27 over 45. And then we'll go over to our calculator and just simply type that in. 27 divided by 45 is 0.6. And then we're going to apply our inverse cosine function to get 53.1. So theta is approximately 53.1 degrees. Excellent work. So these are solving the missing component problems. Hopefully you all are feeling more comfortable solving these. Let's move forward. Now we want to find the following. We want to find sine of 60, tangent of 30, and cosine of 45 degrees. So to solve these problems, we need to draw a triangle. We need to create our own triangle. And hopefully, oops, what's happening here? Sorry about that. So let's draw our triangle. Let's create these. So let's create a right triangle. And our first one is sine of 60. So we'll say this is equal to 60 degrees. Okay. Therefore, this is 30 degrees. Now, there's something you all should know. Y'all should all know the special right triangles, the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. So this is a 30, 60, 90 right triangle. So we know the side opposite 30 degrees is some side length s. Opposite the 60 degrees is some side length s times square root of 3. And the hypotenuse is some 2 times s. So if we want to solve for sine of 60 degrees, we need to be thinking of SOH-CAH-TOA. And we need to know that sine is equal to the opposite over our hypotenuse. So in this case, opposite 60 degrees is s root 3. So sine of 60 degrees is going to be equal to s square root 3 over our hypotenuse, which is 2s. Our s's cancel out, and we see that sine of 60 degrees is equal to the square root of 3 over 2. For this same triangle, we can solve the tangent of 30. I'll change colors, but tangent of 30, tangent is opposite over adjacent. So the opposite side to our 30 degrees is s, and the adjacent side is s root 3. Therefore, tangent of 30 degrees is equal to s over s root 3. Our s's cancel out. Now, we can't have a radical in our denominator, so we're going to multiply both our numerator and denominator by square root of 3. And once we do that, we're left with square root of 3 in our numerator and 3 in our denominator. So tangent of 30 degrees is equal to root 3 over 3. Excellent, excellent. Now, lastly, we want cosine of 45 degrees. So we're going to have to draw our second special right triangle. Let's go ahead and sketch it. So here's another right triangle. Come on. Here we are. So for this special right triangle, this 45, 45, 90 right triangle, you should know that the legs are both some side length, and the hypotenuse is some side length times the square root of 2. Cosine is adjacent over hypotenuse. So adjacent is s, and our hypotenuse is s square root 2. And so this is what equals cosine of 45 degrees. Again, we can't have a radical in our denominator. So we're going to multiply both sides by the square root of 2. And we're left with s root 2 over 2s. Our s's cancel out, and we're left with root 2 over 2. So cosine of 45 degrees is root 2 over 2. So there's how we can use our special right triangles to solve for different values for our trig functions. Let's continue. We only have a few more problems left. So these problems are multi-step solve the missing component problem. So let's check out this one. We want to solve for x, but we can't directly solve for x. We don't have enough information. So how can we solve for this variable? Well, to solve for a missing component, here I'm going to move myself over to this corner. So to solve for this missing component, well, notice that we kind of have two triangles here. We have this one up top and this one down below. We need to first find this length, the hypotenuse of our top triangle, and we need to find it because it is shared between both of the triangles. So let's find this length first. And that's something we're able to do, as if we call this hypotenuse, let's just call it h for hypotenuse, then what do we have? Well, we know that this angle is 51 degrees. We have what do we have? We have the opposite side, and we have the adjacent side. So we can use tangent of 51 degrees. We can have tangent of 51 and set this equal to, here I need to move myself again, move myself down here. Tangent of 51 degrees is equal to the opposite h over the adjacent side, 14. Therefore, my hypotenuse, if I multiply both sides by 14, is equal to 14 times the tangent of 51 degrees. Now I can put this into my calculator and have some value for the length of h. So let's go ahead and do that. We have, let's clear this out, 14 times the tangent of 51 is 17.3 once we round it. And now we can use that value to solve for x. Oh, excuse me. This monster is getting to me. We can use this value to solve for x. Now looking at this top triangle, we have this 72 degrees here. Side x is adjacent to it, and h is the hypotenuse for this triangle. So thinking of SOH-CAH-TOA, we're going to need to use cosine now. We know that the cosine value of 72 is equal to the adjacent, our x, over our hypotenuse, which we just found to be 17.3. So now, whenever we multiply both sides by 17.3, we will find our missing value x. So let's go ahead and do that. let's clear this out. 17.3 times the cosine of 72 is 5.3. So x is 5.3. All right, so this is as hard as it gets for these missing component problems, wherein you have to solve for one value before you can solve for what you are looking for. Let's go ahead and solve this next one. Here, let me clear up some space. And go ahead and pause the video and try to solve it on your own. But let's go ahead and get right to it. So we're looking for x, and x is just this length, the bottom part of the triangle on the right. So again, before we can solve for x, we need another piece of this triangle before we can solve for it. And so we're going to solve for the shared piece. And the shared piece in this case is this altitude, this drop down. That length is both part of the left triangle and the right triangle. So we're going to solve for it first. Therefore, we can then solve for x. So let's call this altitude, let's just call it a. And to solve for a, let's think of SOH-CAH-TOA. And what are we going to be using? Well, from the perspective of the 54 degrees, what do we have? Well, we have the hypotenuse, and we're looking for the opposite side. So we're going to be using our sine function. So we know that sine of 54 degrees is equal to our opposite, a, over our hypotenuse 20. Therefore, a is equal to 20 times the sine of 54. And here we can just plug this in to get a value. So 20 times the sine of 54. That's going to be 16.2 once we round it. So a is equal to 16.2. That's our altitude. And now we can solve for x, our unknown. Okay, in terms of 28, what do we have? Well, we have our altitude. That's our opposite side. And we're looking for our adjacent side. So we're going to be using the tangent function, such that the tangent of 28 degrees is going to be equal to our altitude, which we found to be 16.2, and we're going to be dividing by our unknown x. Here, let me move myself again to the other side. Now, to solve for x, what are we going to do? Well, we can multiply both sides by x, then divide by tangent of 28 to get that x is equal to 16.2 divided by the tangent of 28 degrees. And now we can just plug this into our calculator to find our answer. Okay, 16.2 divided by the tangent of 28 is 30.5 once rounded. So x is equal to 30.5. Excellent job. If you got that on your own, give yourself a pat on the back. Again, this is as hard as it gets for solving these types of problems. And let's solve this last one. Let's check it out. So what do we have? We have these two pink triangles. You have these two pink triangles. And we're looking to solve for theta for this problem. We want to solve for the missing angle. Again, before we can solve for theta, we need to share we need to solve for the shared component. And the shared component is this split line here. Let's first solve for this piece. And then once we solve for that piece, we'll be able to solve for theta. This split piece is the hypotenuse for both of these triangles. So let's just go ahead and call it H. And let's look at the triangle on the right first. What do we have? Well, we have the opposite side, and we're looking for the hypotenuse. So when we think of SOH-CAH-TOA, we know that we're going to be using our sine function. So sine of 54 degrees is equal to 18 over h. We can multiply both sides by h, then divide by sine of 54 to get that h is equal to 18 divided by sine of 54. And we can, of course, now plug this into our calculator. So we have 18 divided by sine of 54 degrees, and that's 22.2. Now let's solve for theta. So in terms of theta over here, what do we have? Well, we have the adjacent side and we have the hypotenuse. So we're going to be using our cosine function. And what do we know? Here I'll move myself again. What do we know? We know that cosine of theta is going to be equal to the adjacent side 17 over our hypotenuse 22.2. And then to solve for theta, all we're going to do is apply the arc cosine function to both sides, and we'll get that theta is equal to the arc cosine or inverse cosine of 17 over 22.2. So let's plug this into our calculator. Let's clear this out. So 17 divided by 22.2 is this value. And then we want to apply our arc cosine, and we get 40 degrees. So theta is equal to 40 degrees. And there you go, guys. There are some 10 trig problems for you all. If you found this video helpful, let me know down in the comment section below, and I'll see you in the next one.